In this video, we are going to look at how to determine the enthalpy change for a reaction given the heat of formation values, or enthalpy of formation. So the way that you know that you have enthalpy of formation values is by this subscript of an F next to the values that are given. And notice that the enthalpy of formation values aren't for a whole reaction, they're just for a particular substance, either a reactant or a product. And so when we're using enthalpy of formation values to find the enthalpy change for a reaction overall, we do the sum, and so this symbol right here means the sum of the delta HF values of the products minus the sum of the delta HF values for the reactants. So that's what we have to do here, and we also have to look at the coefficients in our equation, because this is the enthalpy of formation of 1 mole of each of the substances, but for some of our substances we're not going to have 1 mole, we have more than 1 mole. For instance, for F2 we have 4 moles of that substance, so we have to pay attention to that as well. So let's go ahead and we'll do our reactants in blue, and we'll do our products in red. Okay, so we're first starting with our products, which we're doing in red. And so let's look for the value of HF, our heat of formation for HF. And notice we have 2 HF, so whatever that heat of formation for HF is, we're going to have to multiply it by 2. So 2 times the value of HF, so I found HF right here, and the enthalpy of formation is negative 273. So 2 times negative 273 kilojoules. And notice per mole, meaning that we have 2 moles, so we're doing this twice because we have 2 moles of it. So there's one of our products, and then our other product is this SF6. Which is right here, and its delta H value is negative 1220 kilojoules per mole, and we only have 1 mole of SF6, so we just need to do plus 1 of that, negative 1220 kilojoules. Okay, so there are our products, and I'm going to label them so we don't forget. And then we are subtracting our reactants, so minus, and then we're going to do our reactants in blue. Okay, open up a new set of parentheses. So one of our reactants is this H2S, which we only have 1 mole of. So H2S, 1 mole, so it's just negative 21 kilojoules. Okay, and then our other reactant is F2, which we have 4 of. F2, but its delta H of formation is 0, so we're doing 4 times 0 kilojoules, which is obviously going to be equal to 0, but I'm still going to write it in so we don't forget that we've added it up. 4 times 0, and this is our reactants. So really this problem is just about multiplying and adding, and that's pretty much it. The tricky part is making sure that we have our negatives and positives correctly. So I'm going to go ahead and combine some of these terms and make sure that we're doing all of our math properly here. So let's see. So let's put the calculator here. Let's go ahead and do 2 times negative 273, 2 times negative 273, which gives us negative 546. Okay, and I'm going to leave off my units here. I know my final units will be kilojoules. So we combined that first section plus negative 1220. Okay, and then on the other side of my reaction, I know that I'm going to subtract between these two things, but then in my other set of parentheses, I have negative 21 plus 4 times 0, which I know this is going to be this right here is going to be 0, so that's going to go away, so I just have my negative 21 kilojoules on the other side. Alright, going back to my product side, I'm going to add these two values together. A negative plus a negative should give me another negative, so negative 546 plus negative 1220. That gives me negative 1766. Okay, coming back to my other side, minus, I'm keeping that negative sign carefully, minus negative 21. Alright, so now I just need to combine these last two values. I'll do that in black. Minus negative means I'm going to have negative 1766. Minus negative means I'm plussing, because the negatives cancel out, plus 21. So negative 1766 plus 21 should give me negative 1745. And of course I know my units are kilojoules. And that is my final answer.